This is my video for Lab 1, Excess Charge on an Ordinary Object. In order to quickly introduce the lab, we created several experiments with clear Scotch tape in order to display the interaction between charged objects. We created this tape by peeling two pieces of tape apart, leaving us with a charged U-tape. We mainly determined approximately how much excess charge was on one piece of clear tape, and then used this to create a computational model to demonstrate what we learned. There are two fundamental principles necessary to understand the contents of this lab. The first is Coulomb's law, which essentially states that opposite forces attract and like repel. This law allows us to not only calculate the electric force between two charges, but the electric field created by a single point charge. This is really helpful in this lab as we can use it to estimate the electric charge on one piece of tape. Another important scientific principle is Newton's second law, force equals mass times acceleration. What's important here is that if an object is not in motion and its acceleration is zero, that means that all forces acting on it must also be zero and must also be equal. First, we created two U-tapes using the method described before. In order to figure out if the U-tapes were positively or negatively charged, we took them close to a negatively charged pen. The tape was attracted to the pen, meaning according to Coulomb's law, the tape is positively charged. Now, both pieces of tape repelled each other, meaning, according to Coulomb's law, once again, that they have the same charge. The main part of the experiment was set up by taking tape B and placing either end on a book, leaving the middle hanging down low. Then tape A was brought to the underside of tape B, causing it to essentially float in the air. The electrical force from tape A was acting on tape B and causing it to float. The next step in the experiment was calculating and measuring data. First, we had to find the mass of the tape, which came out to be 0.21 kilograms. The distance between the two tapes was measured and came out to be 0.018 meters. Then, using the mass of the tape, which was earlier calculated, we were able to find the magnitude of gravitational force on the floating tape, which came out to be 0.21 newtons. Now, conceptually, we were able to use this force of gravity to find the magnitude of the electric force on the floating tape. Since the tape is floating, all forces are equal, since its acceleration is zero and it's not moving. So the electrical force is 0.21 newtons also. This can be seen in the force diagram on the right. In the x direction, we have the two tension forces from the books, both equivalent. And then in the vertical y direction, we have the electric force and the gravitational force. These are also equal since the tape is not moving and the acceleration is zero. Now we have all the information necessary to make our final calculations. The estimated excess charge on tape B using Coulomb's law and setting the electric force equal to the gravitational force came out to be 8.7 times 10 to the negative 8 coulombs. We were then able to calculate the number of deficient electrons, which came out to be 5.4 times 10 to the 11th electrons, the number of atoms on a piece of tape, which came out to be 2.1 times 10 to the 9 atoms, and then the ratio number of deficient atoms to the number of atoms on the tape surface, which came out to be 257 electrons to atoms. This is the program I created in Python to demonstrate this experiment using Newton's and Coulomb's laws. It will output the necessary charge to float tape B above tape A a certain distance. It takes in a certain distance between the two tapes and will output the minimum necessary charge as demonstrated in this video. The charge can change based on distance. See how the charge increased with distance? The model outputs the same minimum charge necessary to float tape B above tape A that I found of 8.7 times 10 to the negative 8 newtons, and the program also uses three assumptions that simplify the code. In conclusion, if electrons had positive charge and protons had negative charge, there would be no change in the interaction between objects on a macro level. Like charges would still repel and opposite charges would still attract, as per Coulomb's law. Now, it was important to handle the charged tapes as little as possible because when coming in contact with oppositely or neutrally charged objects will lose their charge as electrons move from high density to low density areas.